the first question or the first approach we can ask, by the way, is my camera on? Yeah. Is whether AI can identify relevant references. So the idea for this would be that we can retrieve, or whether we can retrieve relevant studies for a research question without complex search strategies or even without searching several different data sources. It's important to note that this only works if we can combine AI, or usually large language models, with an actual information retrieval system. And this approach might appear attractive because you don't need to formulate a complex Boolean query, and ideally the results should be more precise. That means there should be fewer irrelevant hits. But there is an important disadvantage that is that it makes the information retrieval process itself quite intransparent and non-reproducible, and we also don't know how complete the result is. So this means it doesn't meet the methodological criteria that we have for a systematic search proper. However, these kind of approaches can still be useful for the parts of the systematic search process that do not have these requirements. So Maria Inti mentioned at the start of the process, you need to identify seed references. You usually do that with exploratory searching of some kind. And these type of approaches can be useful for that. They might also be useful at the end of the process for surveillance searching, where you check if a review should be updated. There are many different tools that can be used to do these types of searching. I want to look at some examples. Obviously, this is not an exhaustive list, but in general, we can see different approaches. One approach would be academic search engines with large language model support, like Elicit and Consensus, where you can actually ask a research question and get results. And both of these tools use Semantic Scholar as data source, and both provide a written answer to the question based on top papers and a larger list of results. They also offer filtering and even additional data extraction options. However, the disadvantages we see with that is that that these tools still retrieve irrelevant articles, and sometimes the summaries and the data extractions can be incorrect or misleading. I want just to quickly show an example for a concrete research question where we have a summary and Elicit. And when we read the summary and compare it to the research question, we see that only of the 4 papers used in the summary, only one of them is actually relevant to the question. And also in the list of results, we see that there is a mismatch between the research question and the filtering and what is actually retrieved by the search. So this type of searching can give us an overview of the evidence base, but it's unclear how complete it is, and it still contains irrelevant references. Another approach could be using seed citations as the basis for searching. Examples for this are Research Rabbit and the Semantic Scholar research feed, but there are obviously a ton of different tools. The advantage to classical forward and backward citation searching is that because of the AI supported ranking and filtering, we get more precise results, and also we can use newly identified relevant articles to add them to the seed citations, and that way continuously improve the further suggestions. The drawbacks of this approach differ depending on how the system actually works, but none of these types of tools are really made for the high sensitivity and very transparent searching that we need in the systematic review. But still, both these seed reference type of search tools and the tools like elicit and consensus um, may be useful for the steps of the search that do not be that don't need to be transparent and sensitive. So, as I said, exploratory searching or maybe topic surveillance. Another question that has often been asked is if AI can help us design search strategies, so database search strategies. And there is quite a lot of research in this area. Most of the studies focus specifically on testing ChatGPT to design searches in PubMed. And PubMed here is an obvious choice because it's freely available and the data about its syntax and its mesh catalog and so on are also freely available. Um, the potential advantages of such an approach would be that maybe it could lead to fewer errors in search strategies, and it could be quicker to design searches this way to quickly identify relevant concepts and the relevant synonyms. Um, there are quite a lot of potential disadvantages that have been widely discussed and pointed out. Some of them are related to the large language models in general. So the variation in output depending on prompts, but also the variation in output for the same prompt, hallucination in that case, hallucinating controlled vocabulary, but there are also concerns that are specific to the requirements of database searching. Um, for example, if the output in database syntax is correct, and if the balance of recall and precision is adequate for our requirements of a systematic database search strategy. Because this approach appears to be the most popular when it comes to recent discussions concerning AI and systematic searching. I'd like to look at a few papers in this area to give a better idea of the evidence base we have at the moment. What you see here are the prompts from a quite influential study from 2023 by Wang and colleagues. They used ChatGPT and different prompting approaches to create PubMed-specific search strategies. Their reference standard was a set of around 100 existing systematic reviews from two different collections, and they compared their search result against the sensitivity or recall and the precision of the original PubMed searches. And because we know that there is variation in output to the same prompt, they rerun their final prompts several times in ChatGPT and looked at the averages. And their conclusion was that the most promising approach was the one you see on the right-hand side, which is a stepwise, they call it guided approach that goes through the systematic search strategy formulation process step by step. And in their study, they reached a recall of around 50% with that. The next slide are results from a reproducibility and generalizability study of the Wang study I just showed you. The authors here added additional large language models to see if the performance differed. And this table shows the average recall of the different approaches, so the different large language models and the different prompts. The first column shows us the results reported in the Wang study. These are the results by the new study and called baseline. These are the that this is the average recall for the studies, for the search strategies designed by humans. And what we see here is that the human-designed search strategies found, depending on the set, either 71 or 83% of the relevant papers, while the best performing AI designed search strategies had an average of less than 30% recall, which is not really satisfying. And then finally, I want to show you a different approach, which is also using the Wang study as a starting point. Adam and colleagues have the hypothesis that a model that is fine-tuned on actual search queries will perform better than a large language model on its own. So they used an open source large language model and trained it with more than 10,000 systematic review questions and search queries they got from Prospero. It's important to note that for training, they stripped these queries of the database specific syntax. So it only had search terms, Boolean operators, and parentheses. And also the output of their model was equally stripped of database specific syntax. Their reference standard was around 60 existing reviews, and they also compared the performance of their approach to prompts used in the Wang study. We see here the results of that study. We see that the fine-tuned model, which are the results at the bottom, has a much higher median recall or sensitivity than the approach that just prompts ChatGPT. We also see that the fine-tuned model has a performance that is much more similar to human searches, but it still has a much larger variation in recall. And we also notice a certain trade-off. So you see here something called NNR, that is the number needed to read, which means how many abstracts would you need to screen to find one relevant abstract. And here the median human search strategy outperformed the AI designed search strategy quite significantly. So in conclusion, for the question about designing search strategies, based on these studies and available research in general, also some personal testing, it looks like AI designed searches can be run in PubMed, so they work, but they tend to have either a low sensitivity, that means they miss relevant studies, or a low precision, so a higher workload. Or sometimes they have both low sensitivity and low precision. That means they still need to be very heavily revised to be fit for our purpose. And even if the revision itself is done with the help of AI, it still requires some expertise to understand how the search should be revised to be fit for purpose. So it may be useful as a starting point for search strategy development, but it's not useful as an unaudited method for designing search strategies. But even if AI cannot design search strategies, maybe it can help us improve our own search strategies. Interestingly, we didn't find any literature specific on this question. If you know any studies specific on this question, please share it in the chat. I would be very interested. There are some studies that look at that look at the search strategy development process with AI and also look at refining an AI generated search strategy, but that's not really the same. And in our own tests, we used ChatGPT. We saw that generally ChatGPT managed to identify some errors, but not all of them. And maybe more problematically, it also tended to suggest incorrect or inappropriate revisions. So in the example you see in the slide here, the main problem was that it didn't recognize if Ovid Medline syntax was correct. So the problem may be that this is a subscription-based database and interface, and there is less free online information. And so ChatGPT cannot really recognize if the syntax is correct. And in my second example here, we tested a search strategy that had, among other things, a really serious logic error. And ChatGPT was able to recognize that there is a problem. It also suggested some solution, but then it provided a corrected search strategy, which added a new logic error, produced an orphan line, and added an inadequate concept to the search. So obviously, this type of individual testing cannot be compared with the rigorous search approaches we have seen for the previous question. However, I think our experience can lead us to the conclusion that search expertise would be necessary to separate useful from inappropriate suggestions. So using ChatGPT for reviewing existing search strategies is probably also not the most efficient way of going about things. And with that, I will hand over again to Maria Inti.
Yes, thanks, Irma. I hope you can see my screen. So we've been speaking about AI designing search strategies or acting as a reviewer. We're now at the point where we can think about if AI helps us with running search strategies, export and aggregating. So as you know, these are time-intensive tasks. And especially when you have to run searches, update them, or even run them on a very regular basis. And these kind of tasks, so running, exporting, and aggregating, can currently only be partially automated, even though these are the tasks that we would really like to be automated because they are time intensive. And as of now, AI is of no great help with supporting these kind of mechanical steps of a search. Why? Well, because for running, exporting, and aggregating and importing searches, we would need basically scripts that can connect to the APIs of the various databases we use for systematic searching. And these are not openly available for most databases, unfortunately. And the tools we would need would be tools that include functionalities of reference management software. And for now, large language models cannot help us with that. So we are stuck basically with the mechanical tasks and hope to see some improvements that you know might be solved by some kind of software, but certainly not by AI for now. And what is the underlying problem? Of course, the subscription-based databases, which in the health sector, but also in other scientific fields, play an important role and restrict the possibility of automation.